Alright, so I've opened up the flight manual and we're now looking at our performance section. You can see it is given to us in pressure height and temperature. So you go along to the pressure height that we're at for the day, 760 I think it was. We go up to the temperature, which is 35 degrees, and according to the Robinson helicopter figures for an R22 beta, we can only pull just over 24.5 inches on the manifold pressure. That's all we're allowed to pull to get our 124 horses. So if you're pulling more than that, you are exceeding the limits set by the helicopter. Alright, we'll just turn the page and we'll go over to our performance graph. We're now going to our out of ground effect takeoff power or full throttle at 104% RPM. Now, if you look at this graph here, it has gross weight on the bottom. On the side it has pressure altitude, thousands of feet. So if you go along, if you know the weight of the helicopter, you can then go up to the temperature, and we're at 35 degrees. And then you can go across, and according to this graph, around the 3,000 foot mark, we should be able to hover out of ground effect. So according to the graph here, we should be able to do the job at max gross weight. Okay, so according to the graphs, you can probably do the job. However, how old is your Robinson? How many hours has it done? And I won't comment on how many hours it's probably done, but how tired is that engine? How experienced is the pilot? How tall are those trees coming up? What is the actual temperature? What's the wind doing? All these things are going to play roles in your ability to do this job. And it may mean that that graph that we just looked at can be thrown out the window and doesn't hold a lot of stock. It may give you a basis to make some decisions from, but it does not preclude the fact that you're going to have to make decisions based on all these other factors as well. So what we need to do now is physically do a power check to see how much power you have available. What we get people to do when they're going into a confined area is to do a pause check. Now for the pause check to be of any value, you had to have done a hover check when you lifted off from your base pad, wherever that happened to be. Let's just pick some numbers for example. Let's say we're lifting off at sea level. We'll use Maroochydore because that's where we're making these videos. So we're lifting off from Maroochydore, and our elevation is, say, sea level. We now do our hover check, and our hover check consists of one, check that your RPM is top of the green. The Robinson case, 104%. If it was a Bell 47, 3200. You want your RPM at the top of the green, because if it's at the top of the green, you're going to get your second one reading correctly, which is note the manifold pressure required to hover. Let's say, for argument's sake, it's 23 inches today. That's what you were pulling to hover with the load you had on board and the conditions you had. Third thing, you just check your temperatures and pressures, and all your warning lights are out. Number 4, your control response feels normal. Now why do I put that in there? Well, quite normal, yeah, that'll do. Quite often people have lifted up and forgot to take a friction off, or something similar. Someone's sitting on one of the controls. So you want to make sure they feel normal, and that the centre of gravity of the helicopter feels normal. Just check, take a couple of seconds. RPM top of the green, power required, T's and P's look good, controls feel normal, CFG feels normal, move off. Now, this is the important one, because now when you go into your confined area, you have a base power setting that you can use to make decisions on whether you can hover or not. So we've done our hover check. We now head on out to our confined area and we start working. A couple of rules of thumb. In a normally aspirated piston engine helicopter, for every 1,000 feet of height that you go above your takeoff pad, you have to subtract 1 inch of manifold pressure off the top. Now, I'll give you 2 examples. In a Bell 47, Our red line on the manifold pressure gauge in a normally aspirated Bell 47 is 27.4 inches. That's what we should expect to pull at sea level on a standard day. If I go up and I'm 1,000 feet now, I would probably only expect to be able to pull 26.4. If I was at 2,000 feet, 25.4. 3,000 feet, 24.4. So I'm going to be subtracting an inch of manifold pressure off the top. Now in the Bell 47, what you got is what you got. In a Robinson, it's a slightly different case. They've designed that and they've derated the engine. So that, let's say they've got a red line of 25 inches of manifold pressure. You guys probably know that if you kept pulling that collective up, you'd get to about 28. Now you're not allowed to use that. You can if you're getting into dire straits and you're going to bang into a tree. There's nothing to stop you pulling over that to get yourself out of trouble, but you shouldn't as a habit be using all of this. So the inch that you're going to lose off the top, you're not going to notice here, are you? But you will notice it here. So if we take off at sea level and I shut my eyes and I pulled the collective up on the Robinson, I'd probably get to 28 inches. If I got to 1,000 feet, I'll be at 27. If I was at 2,000 feet, 26. 3,000 feet, interesting thing, we're starting to come back to about 25. 4,000 feet, probably only 24. But what happens with the Robinson pilot, he's got so used to just being able to pull that collective and have all the power, once he gets up into these high density altitudes, he does the same thing, and next thing he knows, the power's not there. Bell 47 pilot normally is bred knowing, having power problems. If he pulls up there, the RPM starts to bleed, and he's probably experienced that before. The Robinson pilot can quite often get caught unawares, having never had the power problem in his training, say. So, rule of thumb, for every 1,000 feet that you go above your takeoff pad, take an inch of manifold pressure off the top. Now remember though, if you've lifted off from 1,000 feet, you probably only had 26 available in the first place. So if you go up to 2,000 feet, take it up to 25. Rough rule of thumb. The other rule of thumb, for every 1,000 feet above your takeoff pad, add half an inch of manifold pressure to the bottom. What does that mean? Well, remember in our case where we took off from Maroochydore, we said it was taking us 23 inches of manifold pressure to hover. If we're going to go land at 1,000 feet now, in your head you should be thinking it's going to take you 23.5 inches to hover. Let's say we're going to go and we're going to land at a helipad at 2,000 feet. So we're going to land at a helipad at 2,000 feet above where we're taking off from, and we happen to be taking off at sea level, taking off from Maroochydore. We were expecting to pull about that much today, where it took us 23 to hover at sea level. There we go, 23. However, we're going up to 2,000 feet, so I'm going to have to add an inch, so I'll expect to pull 24 inches of manifold pressure up there. Now, I've got to take 2 inches off the top, so 27.4, 26.4, 25.4. 25.4 is what I would expect to have available to me. Available. What's the difference? The difference, ENC, that's even correct, is, what do we got? 1.4 inches. 1.4 inches of manifold pressure available to me. That is my margin. Now, we've theoretically worked it out before we go. We're thinking, gee, 1.5 inches up my sleeve, I'm going to have to do a cushion creep, maybe a normal type approach, but I'm going to have to watch the steeps. I'm not probably going to be able to do a towering takeoff or a vertical takeoff out of the pad, so I'm going to have to pick a bigger area. Now, we can go and confirm this once we get to the area by doing a power check. Let's have a look at that. Just rub all this out before you recognise all the mistakes I made in my maths. So we're coming up to our helipad and we do a pause check. And the first part of the pause check is P. Need more ink in the pen. P, which is power or performance. Now while we're doing our orbit over the pad, pull full power. Pull it. Alright, the Bell 47, you pull it until you got to full throttle, and you don't want the RPM to decay, but you're just on the verge of RPM decay, and note how much power you have available. Let's say in a Bell 47 you go, gee, I've got 25 inches of manifold pressure. Let's say you're in your R22 and you're going to 2,000 feet. You should be able to get 25 inches of manifold pressure. Now, if you're cheating and doing things like you shouldn't be doing, and you pulled the collective up over the red line, you'd probably find that you'll get around 27 inches. Okay, but then we don't want you doing that, but I'm just trying to prove a point that it's sitting there for you. Now, 25 inches, it took you 23 to hover, add an inch, so you've got 1 inch margin up your sleeve. What type of approach are you going to make? Well, this is where you need some numbers. Alright, let's have a look at what a margin will give you. Now, according to me, and this is only sort of from my experience, other people may have different opinions. If you have a margin between 0 and 1/2 an inch of manifold pressure available to you, you're going to have to do a running takeoff and landing. Right? You're not going to be able to come to the hover and put it on the ground. You're going to have to go into that pad expecting to do a running takeoff and landing. So you need to choose a reasonably large area. If you have 1/2 to 1 inch of manifold pressure available to you, I would expect to do a cushion creep takeoff and landing. In other words, you should be able to hover. If you can't, well, you should be able to 0-0 it straight onto your helipad. But you need to make a shallower approach, arriving at your spot, and you should be able to come to the hover. Your takeoff is going to be long and shallow, so you don't want to be going over big tall trees. You need to choose a larger area, like a football field, to be able to take off for a cushion creep, at least till you get through translational lift. Okay, if you've got 1 to 2 inches of manifold pressure available to you, you should be able to do a normal takeoff and landing, right? Just like you normally would. Normal takeoff and landing with the normal approach paths. If you have 2 to 3 available to you, you should be able to do a towering takeoff. Now, it's a slow towering takeoff, nice and controlled, so that if you find that once you get out of ground effect and you're not getting any wind and you don't have a positive rate of climb in a gap, you can actually abort and put it back on the ground. You do not want to commit too early and punch off into the trees. If you do that and you get to the top of the trees, the towering takeoff is going to very quickly progress into a towering landing. Okay, 2 to 4 inches of manifold pressure. You can do what we call a steep towering takeoff, or it is also known as a max performance takeoff. Now this is one where you actually commit yourself, where you may come up to a very low hover, then pull in full power, steady 29 attitude, and you're gone. And that, if you cannot quite get over a helipad with a towering takeoff, doing one of these will take you an extra 2 metres and maybe get you over those trees and into forward flight. Again, you need to have a little bit of confidence with this one though and know what you're doing. If you've got anything above that, alright, 4+ inches of manifold pressure, oh, forgot my P there, you can go vertical. Vertical approach, vertical departure. So if you've got those margins, and you've done that by doing your power check, you can now make a decision on the type of approach and the type of departure you're going to have to make, and you can then choose the type of area you're going into. Now, some of the problems that guys have is they go in empty. So they do a power check and they have all this power because they took off at a helipad and they were empty, and so it only took them 20 inches to hover. They do a power check, they've got 5-inch margin, they go, oh, I can go vertical, and they go vertical into the pad, but what they do then is they fill the helicopter up. So they then put a 22-stone station or GEO man on board, whoever, some guy that's heavy, he has his rock samples or his carton of beer or whatever he happens to do, and he puts it under the seat, and it's 35 degrees, and the pilot thinks, oh geez, I had heaps of power, now I can take off doing the same thing. He does one of these, commits himself early, he gets halfway through it, and all of a sudden he's finding that he doesn't have the power. The rate of climb wasn't there, so he keeps pulling the collective up, throttles at the hard stop, RPM now starts to decay, and this very steep departure turns into a very steep crash landing, and he whinges and says, oh, I had a partial